Welcome to Investigation 3.1. This is rectangles with fixed areas. So this is our problem launch. And so what I would like you to do, I'm moving stuff around, sorry. What I'd like you to do is add this title, Investigation 3.1, rectangles with fixed area, to your mission in the table of contents, and then please put it on the title of the page that you're going to be writing on. As well, across the title of that page, please put this focus question. When the product of two variables is some fixed number, what is the pattern of change, and how is that pattern of change reflected in tables and graphs of the relationship? So please put those two things in your mission. If you need to, pause this video now. So, what is area? Let's talk about it. If we're looking specifically at area of a rectangle or whatever it may be, what is it? Well, in all reality, it is everything that is inside of that particular object. Every single little bit of stuff that is inside of it. And in order to find the area for a particular rectangle, we have learned in the past that the formula for a rectangle to find the area is base times the height. So depending on what that rectangle is for the base as well as how tall it is. So base times height is our formula for creating a rectangle for finding the area. So taking this concept, we are going to be launching into this problem. So on page 61, if you're following along, it says, in recent years, the populations of many towns have declined and residents move to larger cities for jobs. In the town of Roseville has to plan to attract new residents. So it's sort of stuff that Bozeman is doing. They are offering more amenities to people around, as you noticed in last year. We've gotten an Olive Garden and that sort of thing. So people in Bozeman are slowly being attracted to this place because there's more and more amenities that bigger cities have. Roseville offers free land to homesteaders who are willing to build houses. Each lot is rectangular. Pay attention to that. We're not having any triangle-shaped lots or circle-shaped lots. They're all rectangular and has an area of 21,780 square feet. The lengths and widths of the lots may vary. So that means we could have lots that are closer to a square shape, or we could have lots that are super long and skinny. Pay attention as you create the answers to the problem, or to this problem, and what that means for those lot shapes. The town planners want a quick way to check lot sizes for the new homesteaders. So on page 62, I want you to pay attention to the following. What function or equation relates to the length and width of rectangles with the area of 21,780 square feet? So if we know rectangles are base times height, and that equals area, instead of just writing area, we're going to be writing that 21,780. And I want you to notice the patterns that appear in tables and graphs of that function. This whole investigation is on what's called inverse relationships. So inverse relationships, if you notice, there is nothing about linear in that name. So most likely these are not going to be linear relationships. So, your expectations for today. I would like you to finish as much as possible for this investigation for problem 3.1, and we're going to be doing A through C. So we're doing the entire investigation. So please work yourself through this. If you need any graph paper, it's located at the front of the room. And please add them to your mission if you need graphs for parts A through C. If you have graph paper in your mission, or if your mission is graph paper, use that. However, if you want to not use up entire pages or whatever, you can completely use the graph paper that is located at the front of the classroom. Enjoy the investigation, and on Thursday we will be continuing on with wrapping this investigation up and starting into 3.2. Enjoy and have fun.